So, have you ever wondered how something like ChatGPT actually gets what you're asking? Well, you're about to find out. The answer is this really revolutionary architecture called a transformer. And no, not the robots. This single idea is pretty much the engine behind almost all of modern AI.
And seriously, that is not an exaggeration. From ChatGPT to image generators, this architecture is the foundational building block. If you really want to grasp how modern AI thinks, you've got to understand transformers.
All right, so let's start with the fundamental problem that really stumped AI for years and years. How does a machine get the nuance in our language? You know, in the sentence, "The bee landed on the flower because it wanted nectar," how does it know that it refers to the bee and not the flower? Well, solving that exact problem is why transformers were invented in the first place.
The answer, and honestly, the secret sauce of the transformer, is this brilliantly simple idea called the attention mechanism. This one innovation just changed everything.
Okay, so what is this thing? Well, put simply, it's a way for the AI to focus. As it looks at a sentence, it breaks it down into pieces, or what we call tokens. The attention mechanism then weighs the importance of every single token relative to all the others, figuring out which words are the most relevant to understanding the whole sentence.
You know, the best analogy is a student highlighting a textbook. When you're looking for an answer to a question, you don't give every single word equal weight, right? You scan for and you highlight the crucial phrases. The attention mechanism does exactly that, but for an AI.
And this ability to focus is a total game changer. It means the model can connect a pronoun at the very end of a super long paragraph all the way back to the noun it represents at the beginning. It can understand things like sarcasm, nuance, and really complex sentence structures because it knows which words to link together.
Okay, so we've got this powerful concept of attention, but how does it actually fit into the architecture? Well, it all comes down to a really clever pairing, the encoder and the decoder.
At its core, a transformer is really made of two big parts. First up, you've got the encoder. Its only job is to read the input text, the question you ask an AI, and create this rich numerical representation of its meaning using that attention mechanism. Then you have the decoder, which takes that deep understanding and generates the output, the answer to your question. So it's comprehension, then generation.
Now, there are a couple of other key pieces that make this whole thing work. First, because attention looks at all words at once, the model can't tell the difference between dog bites man and man bites dog. And that's a pretty big difference, right? That's where positional info comes in. It's like a little tag on each word that says, hey, you're first, you're second, and so on. Second, you don't just have one encoder and one decoder, you actually stack them in layers, which allows the model to refine its understanding with each step it takes.
Okay, so this is a really clever design, but why? Why did it just completely take over the entire world of AI? What made it so much better than everything that came before it?
So, why did this architecture win? Well, it wasn't just about being smarter. It was really about being built for massive scale and speed.
It really comes down to these four advantages. And yeah, of course, it delivers superior performance and understands context way better. But the real game changers? Incredible scalability and massive parallel training. Here's the killer feature. See, older models, they had to read a sentence sequentially, one word at a time. It was so slow. Transformers, though, they can process all the words at the exact same time. This ability to train in parallel is what unlocked the era of massive AI models, because we could finally train them on these huge data sets. We're talking huge chunks of the public internet and do it efficiently.
So, let's bring this all together. Let's connect all these technical dots back to the AI revolution that we are all living through right now. How did this one architecture change everything?
The path from this one idea to where we are today is a super direct line. Step 1, the transformer architecture is created. Step 2, its incredible efficiency allows for the creation of what we call large language models, or LLMs, trained on just unimaginable amounts of data. And then step 3, those LLMs become the engines for the AI tools that, we all use every single day.
And it's so important to get this. It isn't just about text anymore. Researchers had this light bulb moment where they realized the same principle of attention could be applied to pretty much anything. The relationships between pixels in an image, notes in a piece of music, even protein sequences. That's why transformers are now the foundation for these powerful multimodal models that can see, hear, and create.
This one architecture, built on the simple idea of paying attention, taught machines to understand the most human thing of all,
our language. It has fundamentally changed our relationship with technology, and it leaves us with a truly exciting question. Now that they can understand us, what are we going to teach them next?